Hello everyone, today we'll talk about the solution to the problem spiral matrix 3. Feel free to pause the video and read the statement, and we'll go on to discuss the solution. Now, when we have a spiral traversal over a grid, over a matrix, there are some ways of looking at it. Sometimes one way is more convenient, sometimes another. In this case, since we are starting in an arbitrary position, we just want to simulate the traversal, because we want to write down the positions that we visit. However, we essentially traverse not just the grid that we're given, we're traversing some infinite grid, but only this rectangle that we're given at the beginning is a rectangle of interesting positions, and we have to write down the order in which those interesting positions are visited. But the traversal happens over an infinite grid. And in that case, we can think about, so we always start going right. So if we go here, then we have to, of course, go one step to the right, one step down, and now we have to go 2 steps to the left. Now we have to go up, again we have to go 2 steps up, and here we have to go to the right 3 steps. Then again here we have 2 elements, so we have to go 3 steps down, and so on. So essentially we go 1 step, 1 step, 2 steps, 2 steps, 3 steps, 3 steps, and assuming that we have that, since the grid is infinite, we don't have to bounce off of any walls or anything like that, we can just simulate it like so. So the first thing to do is, of course, to prepare our list of changes of coordinates for every direction. You have to make sure that this is the correct list in the correct order in which the spiral turns. So that is the correct order here, which would be right, so increasing columns, then down, increasing rows, and so on. Of course, we'll remember the result. And now our simulation will just remember the current direction, the length of our stride that we're taking, so how many steps we have to do in that direction before we change the direction. We'll be performing our infinite walk, our walk along the infinite grid, until we visit all the interesting positions. So if the length of our result is the same as the number of interesting positions, so the size of the rectangle, so number of rows times number of columns, will break out of this loop. And now we know that for the given direction we have to first make enough steps in the given direction. Steps in the given direction, so we just do it. We'll be writing down the position as an interesting one if we're within the bounds, so both row and column are between 0 and the appropriate bound. So this is our check. And in that case we append it to the result. But we still go in that direction, so we still simulate our infinite traversal. So we add the difference in row, difference in column to our row and column. And now every second direction switch, we have to increase the length of our step. So for instance, for every odd direction, we'll have to increase our step. Our direction increases by 1, and of course we have to modulo it with 4. So for instance, we can just check if it's greater than or equal than 4, and in that case, subtract 4. And after that, we'll have rows times columns elements written in our result list. So we just return the result. Also notice that possibly we'll be going a bit longer outside, so after we write the last element, and now suddenly this length of result is already big enough, but this loop will still be going on, because this step can be pretty large, but it doesn't really matter, because if we have written all the rows and columns within our final result list, then the only remaining positions are positions outside of our interesting range. So it might have been possible to break earlier within this loop, but then we'll have to probably make more checks. So this is essentially a little bit of a trade-off, and it's a matter of preference which you prefer, if you prefer to make this check here or here, but it doesn't affect the correctness of the algorithm.